Hello everyone, my name is Mike and today I'll walk through how to install, harden, and verify PostgreSQL on Linux so it listens on its default port of 5432/TCP. I'll also explore multiple methods to secure the database using industry best practices. My sources include the CIS PostgreSQL benchmark, PostgreSQL official documentation, PG audit, and trusted security guides. The goal is to show not only how to get it working, but how to get it working securely and verifiably from Nmap. I'll begin by understanding what PostgreSQL exposes and why that's risky. Then I'll show a minimal install and configuration to make the server listen on port 5432. After that, we'll dig into at least three hardening steps: better authentication, encryption in transit, and access restrictions. Following that, I'll explain how to enable PG audit for detailed login. Then we'll verify from Kelly using Nmap and optionally test with PSQL. Finally, I'll leave you with common pitfalls and key takeaways. PostgreSQL by default listens on TCP port 5432. It access control uses a file called pg_hba.conf, which map clients' IP ranges to allowed users, databases, and authentication methods. Modern version of PostgreSQL supports SCRAM/SHA-256 as the preferred password method, which is much stronger than legacy MD5. For TLS, parameters like SSL underscore min underscore protocol underscore version allow administrators to force a minimal version such as TLS 1.2 or TLS 1.3, helping prevent downgrade attack. These features give us powerful levers to tighten security before external exposure. In a lab setting, the basic steps are: install the PostgreSQL server package, adjust PostgreSQL.conf so that listen underscore addresses includes the interface from which your Kali box will connect. Update PG underscore HBA.conf to allow only the IPs you trust using a secure authentication method. Then start and enable the PostgreSQL service. The key is to allow just enough connectivity so Nmap from Kali sees port 5432 open, but no more. This is the principle of minimal exposure, and it forms the baseline over which we'll apply hardening steps. When it comes to authentication, simply reply on weak or default passwords schemes is a major risk. PostgreSQL support for SCRAM/SHA-256 allow for salted hashes credentials that resist brute force attacks much better than older MD5. The CIS PostgreSQL benchmark strongly recommends migrating away from insecure authentication methods. After setting password underscore encryption equals SCRAM/SHA-256 in PostgreSQL.conf, update PG underscore HBA.conf to require screen for connection. Also, plan a password rotation so existing users stored with weaker hashes are forced to upgrade. Encryption over the wire is non-negotiable. We enable SSL/TLS in PostgreSQL.conf and constrain the setting via SSL underscore min underscore protocol underscore version to require TLS 1.2 or better. The PostgreSQL docs confirm that version prior to TLS 1.0, like SSLv2/3, are disabled by default. You can also specify SSL underscore max underscore protocol underscore version to limit allowed versions. Beyond that, you can provide a custom SSL underscore DH underscore params underscore file for stronger ephemeral keys exchange parameters. Then in PG underscore HBA.conf uses host SSL entries instead of host to require TLS for those client connection. This ensures that authentication and data exchange always occur over an encrypted channel. Even if the port is open, you should strongly limit who can access the database. In PG underscore HBA.conf, specify exact CIDR ranges, ideally only your Kali test box or administrative IPs. After testing, narrow listen underscore addresses so PostgreSQL only binds to internal interfaces. Also, adhere to the principle of least privilege for roles. Avoid giving users more rights than needed. The CIS benchmark specifically calls out excessive privilege as a common misconfiguration risk. Together, this step shrink your exposure drastically. Logging is great, but auditing helps you trace who did what. The PG audit extensions built on standard PostgreSQL login to provide accession levels and object level insight, which is critical for compliance or incident investigation. You can audit selected commands or all statements. AWS documentation shows how PG audit can redact sensitive data like clear text password while still logging DML, update delete action. Just to be cautious about log volume and storage consumption when enabling detailed auditing. To confirm setup, run nmap underscore ss underscore p 5432 server IP. You should see 5432 slash TCP IP. To go deeper, user nmap undersv to see which version is responding. Then try connecting with PSQL using SSL mode equal require from your Kali box. Only if PG underscore HBA.conf allows your source IP and requires scrim over SSL should it succeed. If that works, you have proof that your hardening and connectivity are correct. Some common stumbling blocks are forgetting to allow your testing IP in pghba.conf result in connection refuse, even if the port is open. Enabling SSL but not marking entry as host SSL can allow fallback to an encrypted connection. Switching to Scrim without forcing users to rotate password leaves stale weak credential in use. Also, verbose auditing can consume this space if not managed. Consider log rotation and retention limits. Awareness of these traps help you avoid false negative during grading. To wrap up, you must post Greer listen on 5432 in a controlled manner. Use screenshot to 56 for password authentication. Enforce TLS 1.2/1.3 and tightly restrict access via PG underscore HBA.conf and listen underscore addresses. Optionally, enable PG audit for deeper accountability. Then verify with Nmap and PSQL from Kali. This approach covers configuration, hardening, and verification, turning a working database into a secure one. These references represent research-based sources that guided my configuration and hardening process. This PostgreSQL officially documentation provides technical foundation for settings like authentication, TLS, and host-based access. The CIS PostgreSQL benchmark offers detailed, standardized recommendations for security best practices, such as enforcing SCRM, authentication, and list privilege. I also rely on this guidance for secure database deployments and the PG audit project documentation for auditing and accountability features. Together, these resources ensure that every configuration and hardening steps I implemented was aligned to real world standards. Thank you.